Quadratic functions are always there on the SAT, and mastering them could be your game changer. In this video, we will break down how to recognize, analyze, and solve any quadratic function question that comes your way, from intercepts to axis and vertex of the parabola, and also the different forms of the quadratic function. The general form of a quadratic function is f of x equals ax squared plus bx plus c. We can also write it as y equals ax squared plus bx plus c, which we call the equation of a parabola. Whenever you come across a second degree function, it's quadratic, where x is the variable and f of x is the corresponding output of the function. The constant c here represents the y-intercept of the parabola. For example, if f of x equals 2x squared plus 3x plus 4, then to find f of 3, we just plug in 3 in place of x. So x equal to 3 is the input, and f of 3, which equals 31, is the output, which we also call the y. So the corresponding point in the xy plane would be 3, 31. Next, we'll think of the intercepts, axis, and the vertex of the quadratic function. To find the x-intercepts of the parabola, we need to solve for the points where the graph crosses the x-axis. For example, to find the x-intercepts of the function, f of x equals x squared minus 5x plus 6, we could either factorize the given quadratic, or we could also type the same equation in Desmos and get the graph and see where the graph crosses the x-axis. When we factorize and to get the x-intercepts, we need to reverse the sign. For example, here we have the factors as x minus 2 and x minus 3. So the x-intercepts would actually be 2 and 3. And the actual coordinates are 2, 0 and 3, 0. The axis of symmetry is an imaginary line that divides a parabola into two symmetrical parts. To find the equation for the axis, we can use the formula x equal to minus b by 2a, or we can also do the average of the x-intercepts or any two x values where the corresponding y value is same. The point where the axis meets the parabola, we call it the vertex. The vertex is the peak point of the parabola. If we have a U-shaped parabola, then it is the minimum point where the a value will be positive, and if a value is negative, it will be an inverted U-shaped parabola where we get a maximum. For example, for the function f of x equals x squared minus 6x plus 8, the x-intercepts are 2 and 4. So the average of 2 and 4 would be 3, which is the equation for the axis as well as the x-coordinate of the vertex. We could plug in 3 in the function to get the corresponding y value of the vertex. Also, not only the x-intercepts, we could also take the average of any 2 points. Suppose here the x values are 0 and 6, but the y values are same. So the average of 0 and 6 will again give us the same answer, 3. Sometimes in SAT, the question might not ask to solve the quadratic function, but instead it will ask us to find a different form of the same function. If the parabola equation is of the form y equals ax square plus bx plus c. It's a standard form where the constant c represents the y-intercept of the function. And when we factorize it, the constants p and q would be the x-intercepts. And if h comma k is the peak point of the parabola, we can write the function as a times x minus x coordinate of the vertex whole square plus the y coordinate of the vertex. For example, there is a quadratic function f of x equals x square minus 2x minus 15. Here, by splitting the middle term, we can factorize and get the factors. And if the factors are x plus 5 and x minus 3, the x-intercepts would be negative 5 and positive 3. This is the factor form. Also, by completing the square, we can rewrite the same equation as x plus 1 whole square minus 16, where negative 1 comma negative 16 is the vertex of the function. All three forms represent the same parabola. So far, we understood how to calculate the intercepts, the vertex and axis of a parabola, and also the different forms. Now, if the x-intercepts are already given and we are asked to find the quadratic function, we can rewrite it in the factor form and get corresponding quadratic function. So if minus 4 and 7 are the x-intercepts, then the corresponding quadratic function would be f of x equals a times x plus 4 times x minus 7. Similarly, if the vertex of a quadratic function is given, to get the corresponding quadratic function, we can use the vertex form of the parabola, which is f of x equals a times x minus h whole square plus k. So for negative 8 comma 25 as the vertex, the corresponding quadratic function would be a times x plus 8 whole square plus 25.